Researchers have snapped the best resolution view of the Sun ever, courtesy of the Daniel K. Inouye 4-meter solar telescope. The image, which resolves features as small as 18 miles wide 30 kilometers, is an unprecedented glimpse of what the surface of the Sun really looks like. Typical images of the Sun look like this, as captured by NASA's Solar Dynamics Observatory (SDO), in geosynchronous orbit above Earth. This sort of image shows us a certain amount of detail, but it's missing a lot, partly as a consequence of being shot from 93 million miles away. Then again, the SDO is also in orbit, which we know typically allows for much better viewing conditions than any ground-based telescope. What allows the Inouye Solar Telescope to see in such detail compared with the SDO? Adaptive optics, location, and sheer size. At 4 meters, technically 4.24, the Inouye is the largest solar telescope on Earth, and its location at Hawaii is one of the best-known locations for clear sky viewing during the day. The situation appears to be analogous to the relationship between Hubble and some of our largest ground-based telescopes. Hubble has a 2.4-meter lens, while the European Extremely Large Telescope currently under construction in Chile will have a 39.3-meter lens upon completion. Hubble isn't important because it presents us with the largest window on the heavens, but because the specific characteristics of space-based observation give us an additional level of bit depth in areas other than the additional light-gathering capability from scaling up a lens. The Inouye Solar Telescope is expected to cooperate on observations with the already in-orbit NASA Parker Solar Probe and the joint ESA, NASA Solar Orbiter, currently prepping for launch. In this case, the 4-meter telescope was able to make out what looks a lot like peanut brittle. Here's how NASA NSO described the image. The cell-like structures, each about the size of Texas, are the signature of violent motions that transport heat from the inside of the Sun to its surface. Hot solar material, plasma, rises in the bright centers of cells, cools off and then sinks below the surface in dark lanes in a process known as convection. In these dark lanes we can also see the tiny, bright markers of magnetic fields. Never before seen to this clarity, these bright specks are thought to channel energy up into the outer layers of the solar atmosphere called the corona. These bright spots may be at the core of why the solar corona is more than 1 million degrees. These images have been lightly processed to remove noise and enhance the shape of the structures. The full data set is still undergoing scientific analysis. Still, seeing the fine-scale structure of the Sun is a reminder that it isn't actually just a ball of burning gas. The science of how heat is theorized to move through a star and the large-scale structures we observe has implications for stellar theory. It could tell us something about how our own Sun is evolving over its own lifespan, and might even have implications for our attempts to create sustainable fusion power generation on Earth. A better understanding of solar dynamics might also enable us to predict coronal mass ejections in the future, and that could be critically important, given the risk they pose. I'm downright curious to see what kind of new data we'll learn once the Parker Solar Probe, Solar Orbiter, and the Inouye Solar Telescope are online simultaneously. Please subscribe our YouTube channel Listen News here. If you like the video, please like, comment and share the video.